Welcome! Today we'll solve a challenging problem involving implicit differentiation of a trigonometric equation. Let's look at our problem. Given that sine of square root of y equals x, we need to prove that 1 minus x squared times y2 minus x, y1 minus 2 equals 0. Let's start by writing out our given equation. First, let's solve for y. We can take the inverse sine of both sides to get square root of y equals inverse sine of x. Then square both sides to get y equals inverse sine of x squared. Now comes the tricky part. We need to find y1, which is the first derivative of y, with respect to x. Using the chain rule, we'll multiply by 2 times inverse sine of x, and then multiply by the derivative of inverse sine of x, which is 1 over square root of 1 minus x squared. To make this easier to work with, let's multiply both sides by square root of 1 minus x squared. This gives us square root of 1 minus x squared times y1 equals 2 inverse sine of x. Now for the second derivative, we'll use the product rule here. When we differentiate square root of 1 minus x squared times y1, we get square root of 1 minus x squared times y2 plus y1 times the derivative of square root of 1 minus x squared. Let's multiply everything by square root of 1 minus x squared to clear the fractions. This gives us 1 minus x squared times y2 minus x, y1 equals 2. Finally, we can subtract 2 from both sides to get our desired result. 1 minus x squared times y2 minus x, y1 minus 2 equals 0. And there we have it. We've proven the equation through careful application of implicit differentiation, the chain rule, and the product rule. Thank you for watching.